Hello friends, my name is Neetu Chaudhary. I am Assistant Professor of Physics in B.Sc Group of Colleges, Jaipur, and today my topic is cyclotron. We will learn about what is cyclotron, its principle, working and its limitations. First of all, introduction to the cyclotron. Cyclotron is a machine, okay? It's a machine from which we get highly charged particles, and these highly charged particles, they are positively charged particles. Okay, so if they are highly charged particles, their velocity must be high, and if their velocity is high, their energy is high, as kinetic energy is half mv square. That is, if velocity is high, so its energy is high. Okay, now it works on the two principles. First principle is that in an electric field, the particle accelerates, and the second principle is this: in magnetic field, the particle turns around. So on the basis of these two principles, cyclotron works. Now we will see the diagram. We have two Ds, okay, and they are separated by a gap. This gap is not too much, it is small gap, okay, and these are two Ds and they are connected to a potential. This potential is very high, and it is high tension oscillator because it changed the polarity of the Ds. That we will see how, okay. And then two electromagnets, north pole and south pole, and there is an outlet so that we can take out the target, so that we can hit it with the target. Okay, now we will see if it have the potential, okay. So it will have some positive charge and it will have some negative charge. Let us name D1 and D2. So D1 have positive charge and D2 have negative charge. So because of this positive and negative charge, we have potential, and because of potential we have electric field, and because of electric field we have force, as force is Q into E, and it is a charged particle. The source is a charged particle, and force can also be written as ma. So we have acceleration QE by m. So if we have electric field in this region, so particle will accelerate in this region. So we will see if we have this positively charged particle, we take it as a source, so it will acquire some acceleration and it will move inside the D. Inside the D, as it is a hollow enclosed, so its electric field is 0, and because of these electromagnets we have magnetic field inside. So magnetic field is perpendicular to the electric field inside, so the particle will move from here, and because of the magnetic field it will turn around, okay. It will come to this point. Here the velocity is v, so here is also the velocity v, because magnetic field does not affect the velocity. Again, at this point, now the polarity changes. At this point, these points will become the positive points, and these points will become negative. So now electric field will accelerate in this direction, positive to negative. Again the particle will accelerate in this region, okay, and in magnetic region it will stop and it will turn around like this, okay. We see in magnetic field the magnetic force is equal to the centripetal force. This is QVB equals to half mv square. From this we get v is proportional to r. That is, if velocity is increasing, our radius will increase slightly. So it will increase slightly. So again it will hit. Now its velocity will be 2v. So it will come here with velocity 2v. Again it will make a round, then 3v, here 4v, then it will make round. So that its velocity increases step by step, so that its velocity becomes 5v at some time, at which its radius is equal to the radius of the d. At that point it will come out. So as they are positively charged particles, so make them come out, we put the two potentials, negative potential, so that they attract and hit the target. The target can also be a positive, so that's why we put here the negative potential, so that they hit and we get the highly charged particles. This was the working, okay. And limitations, its limitations are it cannot be done for the electrons. As electrons, they have very high, their mass is very low, so they will accelerate so fast and they will step out very fastly. So they cannot accelerate electrons, and even the neutrons, as neutrons are the uncharged particles, so they only accelerate the positively charged particles. So neutrons and electrons do not possess the cyclotron theorem. Thank you.